Welcome to the Crazy Hat Chemist. So here we go with another awesome video on nomenclature. So we're going to get this one started here. And so hopefully everything is going to be awesome. So this is a nomenclature worksheet number 2. And so I'm going to make the assumption that you have done the following prior to this. 1, you have watched my video play series. That is my playlist on chemical nomenclature. This is chemical nomenclature for ionic compounds and binary covalent compounds. You actually know your periodic trend charges. So I'm going to zoom on out on this, and these are your periodic trend charges right here. So group 1 is +1, group 2 is +2, then +3, +4, +5. Roman numeral 5 is a V, and then we count 5. 1, 2, 3, 4, 5. These 5 have 2 different charges, an 2+ and a 3+. If you're using the common nomenclature and not the Roman numerals, then this the lower charge of the 2 is OUS, the higher charge of the 2 is IC. OUS does not mean 2+, and IC does not mean 3+. It just means lower is lower is OUS, higher is IC, as you can clearly see with copper. So you've been traveling along the road here at a speed of 2 and 3, and then, oh my gosh, you see a copper. And what is that copper going to do? Slow you down and slow you down. So decrease both of these numbers by 1 each, and then you get a 1+ and a 2+. And again, the lower charge is an OUS and the higher charge is an IC. Then you have diagonal pattern. That's a silver, zinc, and aluminum. The silver is a 1+, the zinc is a 2+, the aluminum is a 3+, and zinc and cadmium are in the same column, so they both have a 2+. Copper, silver, and gold are all in the same column, so that means they all have one common charge, and that's a 1, 1, and a 1+. And gold is worth more, so it also has a 3+. Mercury has a common charge in this column, and that they are all a 2, 2, and a 2. And then it has a common charge. It's kind of like an intersection between these two columns here, and it also has a 1+. There's mercurous, and that has a subscript 2 right here. And there's mercuric, and that does not have the subscript 2, but they both have the 2+ charge. So the mercurous is like having 2 1+ ions of mercury together. And the mercuric is only a single mercuric there like that. Then we have, so 1, 2, we're going to skip the transition D block elements, and then there's a 3+. Okay. And then we're going to flip on over to the other side of the periodic table because there's this orange staircase line that divides the metals on the left from the non-metals on the right. And with the non-metals, they like to gain electrons, and that's why they have negative charges. So the noble gases, they don't have a charge. Then we have a -1, -2, -3, and ±4, depending on which the element is in this column. Another one in this region here in the P group here is the tin and the lead. And there's a 2 and a 4 for both tin and lead, a 2 and a 4 for both tin and lead. And again, the lower charge is OUS, the higher charge is IC. All right, so a couple other things. We have the special 7s. We actually have 3 different 7s, and those 3 different 7s are the metalloids or semi-metals, and those are on either side of this orange staircase line, excluding aluminum, because that is most certainly a metal. So that would be boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, or this At right here. Okay, and then that's 7 metalloids. And then we have our diatomics, and diatomics are molecules. They are elements that are in the molecular state as a group of 2, if you will. So it's N2O2, F2, Cl2, Br2, I2, and that's in a shape of a 7. There's only 6 of them, and then you're going to have to jump to H2, and that is the 7th diatomic there. So if you play the game of chess, you know that the knight uses this L-shaped pattern, which is like a 7, and it's the only one that jumps. So that's one way to remember that. I'm going to be referring back to this periodic table during this whole entire video so that you should understand that information already on that. All right, so I want to peel that away. And then the other thing that I'm going to expect you to know is that you should know your ions and charges. And I just went over many of them that are right up here in this section. I have divided up the cations and the anions. And then on this lower section here, you should see that these are the transition elements and their charges. And at the bottom here, I'm saying, look for patterns on the periodic table and in formulas which can help you memorize the number of oxygen atoms in polyatomic ions. And that polyatomic ion group is going to be on the back of my sheet of paper. So these are the polyatomic ions right here. There's only one polyatomic cation, and that's the ammonium ion. And there are most certainly many polyatomic anions. And if I slide this all on up here, right over here, then you should see there's more polyatomic anions right here. And then for the binary covalent compounds, you need to be using prefix naming. When naming bases, here are some hints. And when acids, here are some hints as well. If you need this sheet of paper, if you're an instructor or something like that, and you would like this charges on ions and oxidation numbers, you can certainly email me. Crazy Hat Chemist, or you can, shoot me something via my YouTube channel, and I can certainly email this to you. Not a problem. All right, so I'm going to assume that you know your charges on ions and oxidation numbers. A hint on memorizing the polyatomic ions and their charges, and that is, I would highly recommend that you actually just write them out. So, for example, this is probably the fastest, best way to memorize your ions and charges, and that would be doing the following. Just take out a blank sheet of paper and saying nitrate, Nitrate, NO3 minus 1, nitrate, Nitrate, NO3 minus 1. And then I would do the reverse as well, and that's NO3 minus 1, nitrate, Nitrate, NO3 minus 1, Nitrate. Now, many students like to use 3x5 cards and call them flashcards. Well, you just flash it right before you, but you're actually not putting it into your long-term memory. In addition to that, you can make Quizlets and all kinds of other things similar to that. And again, you're not physically writing it down and saying out loud. If you want to spend the least amount of time memorizing anything, then what you need to do is write it out physically and say it out loud. And then you're going to do that in blocks of 10 to 15 minutes. Educationally, this is the fastest way to memorize anything. And if you wanted to, you could be, doing jumping jacks while you do this, or some other activity while you do this. So short blocks of time, 10 to 15 minutes, write it out, say it out loud. It's the fastest way to get these polyatomic ions memorized in your long-term memory so that you can recall them back very quickly. That's essential in this whole entire unit, and it will be essential for the next unit on chemical reactions and the following unit after that, which is stoichiometry, where you actually get to apply all this to some mathematical problems. All right. So without further ado, I'm going to assume that you have periodic trends and charges known and memorized, your polyatomic ions and charges known and memorized. And then we're going to get right into this here. So prior to doing this, this is a front and back of a sheet of paper. There's 50 problems, and they're alternating from name to formula, name to formula. So you have a name, you're supposed to write the formula. You have a formula, you're supposed to write the name. That's the game of this. There's going to be 50 problems here, 25 names, and you have to write the formula, 25 formulas, and you have to write the name. And in saying this, this is kind of a review for an assessment or test. You should be able to do this with only a blank periodic table and nothing else. And you should be able to do these 50 problems in approximately 30 minutes. Okay, that will leave you some time to be checking your work. So that's our plan here. And so we've got 30 minutes or less, and that is obviously, it might take me a little bit more time because I'm going to have to include explanation with each one of these, but you wouldn't be doing that while you're doing this. So you should be able to accomplish these in about 30 minutes, and that will allow you a little bit of extra time, maybe about 10 to 15 minutes or so to actually check your work and go back and do it again. All right. So let's see if we can hammer this out. And oh, by the way, one more thing here. Today's video is sponsored by the Crazy Hat Chemist. That's me, folks. All right. All right. So let's get moving on this problem, these set of 50 problems, and we'll get moving. All right. Talk to you very soon, in just a moment. All right, so here we go. This first one is calcium phosphite. And so calcium is a group 2. And phosphate is a polyatomic ion, PO3 3-. So what we're going to do is take the absolute value of these two numbers, flip the numbers, bring them down, and then we're going to write our formula. So that's Ca3, PO3, parentheses, Na2. That would be calcium phosphite. All right. The next one is ammonium chlorate. Ammonium chlorate. Okay, the next one is perchloric acid, and it does not have a hydro in front of it, so therefore it must be a polyatomic ion, and I'm going to be looking for the chlorate ion. Chlorate ion. And the chlorate ion, the perchlorate ion is ClO4 1-. And all acids have hydrogens associated with them. And so what we're going to do is we're going to take the absolute value of these two numbers, flip the numbers, bring it down. I did tell you, take the bull by the horn, flip, drop it down, and then you get that formula. So it's going to be HClO4. And then some people like to write the aqueous here, although it's not necessary on polyatomic ion acids. The next one here is H2CO3. This 2 comes up. That tells you that this is a 2-, and that is carbonate. This is AQ, and that has a hydrogen associated with it. There are 2 hydrogens because the carbonate has a 2- charge, and this is carbonate. And since this is an acid, this 8 becomes an ic, so this will be carbonic acid. Spelling is essential, critical on all these problems. FYI, just to make sure. All right, so our next one is trinitrogen hex oxide. So this is a binary covalent compound. It's named with prefixes. So we're going to write the 2 elements. Binary is 2 elements. So that's nitrogen and oxide. So nitrogen and oxygen. I'm going to leave a little bit of space here for writing out the tri is for 3, and the hex is for 6. Okay. So hopefully you got that. The next one is Hg2s. And that one, I would highly recommend on any mercury compound that you actually write out both of them. That is my recommendation. You can do what you want, but here is my recommendation. And so let's see if we can do this here. We know that this is a sulfide. So this is going to be some mercury of some kind. So mercury. And I'm going to put a parentheses here, sulfide. And then we're going to figure out what mercury this is. And how we figure this out is what we're going to do is we're going to write out both mercury compounds. So that would be mercurous. This is a 2, and that is a 2, and this is mercury 1. And we're going to do mercuric in addition to this and see which one matches, Hg2 and a 2+. Sulfide is a periodic trend charge right there, and that looks like that. I'm going to take the absolute value of these 2 right here, and I'm going to write that down. I'm going to flip them and bring them down, and they actually reduce. But you cannot remove this 2. So it's going to be Hg2 HS is going to be mercury 1 or mercurous sulfide. And then this next one over here, mercuric or mercury 2, I'm going to do that one as well. We're going to flip these and those both reduce, and I'm going to have HGS. So my recommendation on mercurous or mercuric compounds, mercury compounds, is to make both of them and then compare them to what that formula is. So one of these should hopefully match with that one. It is most certainly that one, and therefore I'm going to write a Roman numeral 1 right there. And then the other naming of this is the systematic naming, mercury 1 sulfide. The common name is mercurous. So mercurous sulfide, that's the common name. All right, so I'm going to peel that away, and hopefully that helped out for you. The next one is ferric, and that is Fe3 plus, and then hydrogen sulfate, that is HSO4 with a 1 minus. Okay, and so that's going to be absolute value of the numbers. Flip them, bring them down. So that's Fe parentheses HSO4 parentheses and a 3. That is going to be ferric hydrogen sulfate. Okay. So hopefully that is looking good for you. Our next one here is we need to take this number, flip it up. That's going to be here. That's our anion. Take this number, flip it up, and that's a 2, and that's plus. So that lets us know that this is iron Roman numeral 2, iron Roman numeral 2, otherwise known as ferrous. And then the this right here is thiocyanate. THIO. I'm missing an O. I apologize. So let's thio. Let me rewrite that. THIO. Cyanate. CYANATE. All right. So again, just make sure that you're checking your work so that you're getting it just like I'm doing right now. All right. Next one is ammonium sulfite. Ammonium is NH4 1 plus. Sulfite is SO3 2 minus. Okay, so I am going to take the bull by the horns, the absolute value of these two numbers right there, NH4 parentheses 2 SO3. Okay, this next one is H and an NO2. It's an aqueous. It doesn't need the aqueous, but we do recognize that this is an acid. So I'm going to get the name of this polyatomic ion, and that's nitrite. Okay, and ite becomes us. So this is going to be nitrous acid. There we go, nitrous acid. All right, the next one is cuprous. Cuprous is the lower charge of the two. There's copper 1, and that's what this is, cuprous. And then oxide, periodic trend charge. You're going to take the absolute value of these two numbers, flip the numbers, bring them down, you get Cu2O. Okay. Sliding this up here a little bit here. All right, there we go. And we have another mercury compound. So again, I'm going to highly recommend that you write out both of them, and that would be a good comparison. So the first one right here is Hg2 plus. So it's Hg2, 2 plus. This is mercury 1 or mercurous. The other one is Hg and a 2 plus. That's a hydroxide. So it's mercury Roman numeral something hydroxide. Okay, and so I need to figure out with this hydroxide, which one is it? So again, you're going to take the absolute value of the numbers, flip them, bring them down. And so I'm going to figure out what these two formulas are. So that flips down, that flips down. This 2 must stay there. So it's going to be Hg2 parentheses OH and a 2. And then this flips and that flips. This is Hg and then OH and a 2. And so the difference here is that that mercurous has that 2. The question is, does it have the 2? That's a no. So that means that this is a Roman numeral 2 because it is the mercury 2 compound, and that is mercuric. So it's either mercuric hydroxide or mercury 2 hydroxide. Okay. So again, it's a really it's a not too complicated, but you should be able to do that in a stepwise fashion. The next one is acetic acid, and that is an acid, so it's coming, the ic is 8. So I'm going to write down the acetate ion. So that's CH3COO minus 1, and all acids have a hydrogen, so I'm going to get 8 CH3COO and an H, and you can write the AQ if you want to. That's not necessary. If you have the condensed formula for acetate, that's C2H3O2, and then you just stick a hydrogen on that one. So that would be C2H3O2 and an H. And what I want to emphasize is that you certainly do not add the hydrogen that I'm underlying to the number of hydrogens that are in the acetate ion. That would be an absolute no-no. That would not be okay. All right. All right. Sliding this up here a little bit. This is an element. It's all by itself. We're just going to write down that element name, and that's iodine. Okay, iodine. All right, next one, tetra, and then hepta. Carbon oxide. Carbon oxide. This is a binary covalent compound because it's using prefix naming. So prefix naming, tetra, like the game Tetris. If you look at the game Tetris, it has blocks of 4 that are falling down from the sky, and you have to rotate and spin them and move them around so they fit in the right spot. So tetra is for 4. Boom. Hepta is for 7. Boom. There we go. Perfect. All right. So hopefully that is looking good for you. The next one is silver, and then this is a polyatomic ion. That's per iodate. So silver per iodate. I do want to mention one other thing here, and on all the ions and charges that have a single charge, you cannot use a Roman numeral. So you never use a Roman numeral with group 1, group 2, silver, zinc, aluminum, and cadmium. Okay, any element that has only one single charge to it. Okay. All right, the next one is Nicholas permanganate. Nicholas is Ni2 plus, permanganate is MnO4 1 minus. I'm going to take the absolute value of these two charges, flip them, bring them down, and I'm going to get my formula of Ni parentheses MnO4 and a 2 outside. Okay, all right, just gonna roll this up here a little bit more. All right. The next one is a lead, and this is dichromate. And so I need to figure out which lead this is. So this is lead and a Roman numeral and dichromate. And I want you to know that I'm just getting the dichromate just from CR2O7, and I know that. And so it's really essential that you know your polyatomic ions and charges. This is why I'm doing this so quickly, if you will. And I mean, I am taking my time because I'm trying to explain this to you. You should actually be doing it in half the time that I'm doing it because I am explaining it at the same time. Now, there are 2 different charges on lead. There's either a 2 plus or a 4 plus charge on lead. So what we really need to do is understand what's this number right here and what's the number outside the parentheses. So both of these numbers here are 1. So I'm going to flip up the 1. I'm going to flip up this 1. I do know that lead cannot be a 1 plus charge, but I do know that dichromate has a 2 minus charge. So it has a 2 minus charge, and I need to maintain this 1-to-1 ratio. So maintaining that 1-to-1 ratio and knowing that dichromate is a 2 minus charge, the lead must be a 2 plus. That gives me a 2 plus right here, and that's a Roman numeral 2. So it's lead 2 dichromate, otherwise known as plumbus. Plumbus dichromate. That would be the other way of doing that. All right. All right, the next one is hydro, root word, ic acid. And this is a binary non-metal acid. So binary non-metal acids, there's only a small hand group of a small hand group of these, okay? And so that would be this, this, this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to get rid of this one because that would be water. So it's HF, HCl, HBr, HI, H2S, H2S, H2SE, H3N, H3P. So that's hydronitric acid, hydrophosphoric, hydrosulfuric, hydroselenic, hydrofluoric, hydrochloric, hydrobromic, hydrotic acids. Okay, and you notice that all of these have a single hydrogen. These two have 2 hydrogens. These two have 3 hydrogens. It's very simple here. So this is hydrofluoric. Fluorine is a 1- charge. I'm going to add a hydrogen to it. Take the bull by the horns, absolute value of those 2 numbers. I'm going to get HF. And this absolutely needs this AQ. If you don't have that AQ on there, then this is not hydrofluoric acid. The name of this compound would be hydrogen fluoride. So 2 completely different things. All right. This next one right here has this AQ. That is letting you know that it is an acid. You can see that it's a binary non-metal acid. It's one of the ones that I just named. So it's going to be hydro bromic acid. So hydrobromic acid. So binary non-metal acids, hydro root word, ic, and then acid. I highly recommend that you watch my lecture video series so that you fully understand this, okay? All right, let's see if we can do the next one. It's stannous chlorite. So stannous is tin, that's SN2 plus. Remember, this is a periodic trend charge here. I have stannous as a 2 plus, stannic as a 4 plus. So those are my 2 tins. And then chlorite is ClO2 1 minus for chlorite. We got stannous chloride. What we're going to do is take the absolute value of these 2 numbers, flip them, bring them down. I get SN parentheses ClO2 parentheses and a 2. All right, cool, awesome. All right, so the next one here, what we need to do with this one here is we're going to take this, and this is a 1, this is a 2. I'm going to flip the numbers and bring them up, and then so I'm going to get SN2 and an O and a 1. Well, this gives me the correct ratio of 2 to 1, but I do need to know that oxygen is only a 2- charge. And if oxygen is only a 2- charge and maintaining the ratio of 1 to 2, then the tin must be a 4 plus charge. And if you have any doubt, you can make that compound and then reduce it. And so that's what's actually happening here. So SN4 plus O2 minus, and if I take the absolute value of these 2 numbers and flip them, bring them down, I get SN2O4, and then I must reduce these. So that gives me SNO2. Is that what I have? Yes, it is. So this is going to be stannic oxide. So stannic oxide for tin, Roman numeral 4, oxide. Now, I am going to give another option here for this. So if you recognize and you really know your polyatomic ions, you can recognize that you could have a parentheses around this and a 1. So now I have a 1 here and a 1 here. I'm going to bring those up. So I got SN1, O2, and a 1. And this is a peroxide. That's a polyatomic ion, which has a 2- charge. So if it is a peroxide and has a 2- charge, then this, keeping this 1-to-1 ratio, this would also be a 2 plus. So that would be stannous peroxide. So that's an alternate name for this same formula. So we're going to also write this one down as well so that you have that. So stannous peroxide. barely enough space to write that down, which would be 10 Roman numeral 2 peroxide. That would be another option for this, okay? So that could be a complicated problem for you, but hopefully that's not too bad. Barium nitride. Barium is Ba2 plus. Nitride is a periodic trend charge, and that's N3 minus. So that's going to be Ba3 N2. Really simple. This is cesium cyanide. Okay, cool. Now what we're going to do is we're going to flip the page and we're going to go to the other side of this. So we're approximately halfway done. And so we're going to continue on and do the second half. All right, so here we go. All right, so let's get on to that second page here. Here we go. All right, top of the morning. Well, not quite. Now, top of the morning, top of the world. Okay, so let's see here. This next one here, an H2SO3, and this is an acid, and this is coming from this polyatomic ion, which has a 2 minus charge, and that is, what is the name of that? Sulfite. So sulfite, and the ite becomes us. And there's a spelling issue with sulfuric and sulfurous acid, and we just have to memorize that then. So this is sulfurous acid. So there's a UR that comes in between this. You're just going to have to memorize that for sulfuric and sulfurous acid. So this is sulfurous acid. Okay, the next one is ammonium perchlorate. That is NH4, 1 plus, and perchlorate is ClO4 minus 1. Absolute value of the charges, and then flip them, bring them down, NH4, ClO4, ammonium perchlorate. Then the next one here, I'm going to take this 2, flip the numbers, bring them up, and I should see that I get that Ni2 plus Cl1 minus. I'm going to validate that the chloride is a 1 minus charge. It is. And is there a nickel that's a 2 plus? Absolutely. I am looking at my periodic trend charges. There's a nickel that's either a 2 or a 3, so that does make sense. So this is nickel, Roman numeral 2. Chloride, or the alternate way of writing this would be Nicholas. Chloride. Either one is perfectly fine. No difference between the two. The next one is zinc hypochlorite. So zinc is a periodic trend charge, 2 plus. Hypochlorite is ClO1 minus. So take the absolute value, flip it down, and I get, whoops, zinc, that's the N, ClO, parentheses, and a 2. So zinc hypochlorite. The next one is cadmium and then arsenate. Cadmium is a 2 plus charge. Arsenate is a 3 minus charge. So cadmium. Arsenate. That's just a polyatomic ion. Again, if you've memorized your polyatomic ions, that's very, very fast. So let's move this on up just a little bit. Here we go. Do you know that this video is brought to you by the Crazy Hat Chemist? And you can find me on YouTube. In fact, you're watching YouTube right now. Unbelievable. All right. Maybe you can watch some of my cooking videos. Hopefully I'm going to have some more cooking videos coming out soon. But right now we're working on this one here. So learn a little bit of chemistry. Nothing wrong with learning some chemistry here. All right, so the next one is plumbic. That is lead, which is a 4 plus charge, and thiocyanate. Thiocyanate is SCN with a minus 1. Going to take the absolute value of these two charges, flip the charges, bring them down. You get PB parentheses SCN parentheses and a 4. Okay, this next one here is a special compound. It's kind of like this compound here of H2O. Okay, this is dihydrogen monoxide, but we don't say dihydrogen monoxide. We just say water, and even a chemist would say water. Okay, and then this thing is the same kind of thing. Instead of nitrogen trihydride, it's actually ammonia. So this is going by a common name. You should definitely know ammonia. All right. Next one is ferrous borate, and ferrous is Fe2 plus, borate is BO3, 3 minus. I'm going to take the absolute value of these two numbers, flip them, bring them down. I get Fe3 parentheses BO3 and a 2. That one is a nice looking one, right? The next one. Oh my gosh, there is another mercury compound. So let's see if we can write the two possibilities out for that one. All right. So let me get a piece of paper here and plug this over here. And again, after you do these enough times, you should actually be able to do it just by looking at it. But I'm trying to show you how to do all the mercury compounds so that you never mess them up, and you'll always get it correct, and it actually is less time this way. So mercury 1 is Hg2, 2 plus. Mercury 2 is Hg2 plus. And this is iodide. So I, 1 minus, I, 1 minus. So really, just from what we have here, we can write mercury, parentheses, iodide. But we need to figure out what goes inside the parentheses. So we're going to take the absolute value of these two and bring it down, and we're going to get Hg2I2. We're going to take this one, bring it down, and we're going to get Hgi2. So we need to figure out which one of these two matches. And there's that little 2 there is the essential 2 that's important. So that's mercury 1. And so we're going to write mercury 1, and that's mercurous. Iodide, same thing. All right. So I highly recommend, again, with any mercury compound, they're one of the most difficult ones to do. Write both of them out and then compare them, and then you got your right answer. The next one is aluminum. That's Al3 plus. That's a periodic trend charge. And then oxalate. That's C2O4, 2 minus. And no, you can never reduce it to and that 4. That is that polyatomic ion. That's the way it is. So we're going to take the absolute value of these two numbers, flip them, bring them down. You get Al2, parentheses, C2O4, parentheses, and a 3. Next one, we're going to take these two numbers here. That's a 3 and that's a 2. Flip the numbers, bring them up. That's a 3, that's a 2. And we're going to look at our periodic trend charges, and zinc is a 2 plus. So this is just zinc. And then nitride. And again, nitrogen is that IDE ending on the nitride. That makes sense, hopefully. And that is right there. That nitride is that 3 minus charge, and that should hopefully make sense. Next one here is auric. That's AU, that's gold, 3 plus charge, and acetate, CH3COO minus 1. I'm only going to write the single formula. One of the formulas for acetate, there is another one, which is C2H3O2. That's the condensed one. And chemists generally don't like that one. That's not the one that they like. They like other ones. So I'm gonna skip that one here. Okay, so we're going to take the absolute value of these two charges, flip them, bring them down, and I get AU parentheses CH3COO parentheses and a 3. Boom, looking good. All right, this next one here, I'm going to take that number, flip it, bring it up, and this number 1, flip it, bring it up, and this is cobalt, Roman numeral 2. Roman numeral 2. It's also cobaltous. And then dihydrogen phosphate. I just ran out of a little bit of space. So I'm going to put that right there. So this is cobaltous because it's the 2 plus charge, cobaltous dihydrogen phosphate, or cobalt Roman numeral 2 dihydrogen phosphate. Either one will do. So it's entirely up to you which one you want to write down. All right. The next one is cupric, that is Cu with a 2 plus, and then hydrogen carbonate, that's HCO3 with a 1 minus charge. You're going to take the absolute value of these two numbers, flip them, bring them down, and that's Cu parentheses HCO3 parentheses and a 2. Okay. Slide this on up here. And there we go. We have a binary covalent compound. And so we're going to use prefix naming. So 2, the prefix for 2 is di. So di, and that element name, nitrogen. So the first word is dinitrogen. And then penta, oxide. Okay, so one of the rules here is, and you've got to watch my playlist and nomenclature, and then I will give many examples therein that you should see that I've gone over this. But when we have the A and the O, we always leave the element vowel, and we chop off the prefix vowel. So this is going to be pentoxide instead of pentaoxide. So make sure that you look at that very fine but very important detail. All right, so hopefully that is good for you on that one. Our next one is potassium. That's a group 1. That's a +1 charge. And then thiosulfate, and that is S2O3 with a 2 minus charge. You're going to take the absolute value of these two numbers, flip, bring it down, and you're going to get K2S2O3, just like that. Okay. The next one is sodium. And when either a alkaline metal, which sodium is one, or an alkaline earth metal, which would be like magnesium, so that is group 1 or group 2, is with a hydrogen, then hydrogen takes the non-dominant charge, if you will. So that is group 1 and group 2. The alkaline metals and the alkaline earth metals are always just a +1 or a +2. That is it. And they'd have no other alternate charges. So therefore, that hydrogen must have the alternate charge, and that's a hydride. Hydride, and that is, this hydrogen is a -1 charge. That's the alternate charge is what I'm talking about. All right, stannous hydroxide, that's SN2 plus hydroxide OH -1, that's SN parentheses OH and A2. Many people discount and don't write these parentheses around hydroxides when you have more than one, but it's essential that you have it there like that. All right, our next one is going to be silver. And then this is either silver oxide or silver peroxide. So silver, Ag, is a single 1+ charge. So that means a 1 must come up here. That means that this 2 cannot come up. That means really that there's a parentheses and a 1. And when that parentheses comes up, when the 1 comes up outside that parentheses and that 2 comes up, you should see that this O2 2 minus is a peroxide. That's going to separate the A's from the B's, actually, on a problem like that. Same with all the mercury compounds. Then we have stannic, that's the higher charge of the tin, and that's 4+. Nitrite, ite is NO2 -1. So that's SN parentheses NO2 parentheses and a 4, just like that. All right, looking good. This next one is we're going to take this number, flip and bring it down, flip and bring it up. This number, flip and bring it up. And that's manganese. And this number is a 2. So it's a Roman numeral 2, or MANGANOUS, manganese. And then this is hypochlorite. Perfect, just enough space to write it. And again, just double checking, not checking, I don't know what that is, but double checking. We have these 5 elements. So 1, 2, 3, 4, and 5. And manganese is one of them. And for manganese, there's a 2+ and a 3+. So hopefully that makes sense for you. All right, scrolling this on up here. And there we go. This next one is hydroic acid. And the root word is in the middle. So the root word is sulfur. What's the charge on a sulfide? That's a 2-. It's hydro root word ic acid. That is a binary non-metal acid. All acids have hydrogen associated with them. So this is going to be taking the bull by the horns, flip, bringing it down. I get H2S, and I must have the AQ. With the AQ, it's hydrosulfuric acid. Without the AQ, it's hydrogen sulfide. Without the AQ, hydrogen sulfide. With the AQ, hydrosulfuric acid. Okay, so make sure you understand the difference. This next one here, I'm going to take this 3, flip, bring it up, and I get the charge on the phosphate, which is a 3-. I'm going to take this 4, bring it up, and I get the charge on the lead, which is a 4. So that's a lead, Roman numeral 4, phosphate. Alternatively, this would be plumbic phosphate. All right. Next one is barium iodate. Barium is a 2+, iodate, IO3 1-. And I already gave you my joke on the iodate. I don't date anymore because I am married to my beautiful wife from Spain. And so we're going to take the absolute value of these 2 numbers, flip and bring it down, and we get BA parentheses IO3 parentheses and a 2 outside that parentheses. All right, next one, there's a number here. I'm going to flip that number up. That will give me the charge on that polyatomic ion, which is correct as a 1- for acetate. And then this 2 flips up, and that is a +2 charge on a lead. So that means that this is lead, Roman numeral 2, or plumbus. And then this polyatomic ion, which is acetate. So that means that this is plumbus acetate or lead Roman numeral 2 acetate, either one. All right, and then this is going to be our very, very last problem on this here, and then we will do 50 of them. Okay, and this is nitrous acid. Notice it does not have hydro in front of it. No hydro, that means that this is a polyatomic ion. So OUS goes with ite. So nitrite. What is nitrite? NO2 -1. All acids have hydrogens associated with them. So I'm going to take the bull by the horns. That's absolute value of those 2 numbers. Flip, bring it down. HNO2. And you can either write the AQ or not write the AQ. It's entirely up to you, whatever you want to do. I hope you enjoyed that video. I am the Crazy Hat Chemist, and I would greatly appreciate it if you are learning some chemistry throughout all my videos. Please like and subscribe. Give me some comments. I'd greatly appreciate it. Please watch my lecture videos as well. They give you the foundational material on how to do these problems. So I hope you have a great morning, a great afternoon, and a great evening. And I will see you next time for another great video on chemistry, or maybe even cooking. So see you then. Talk to you later. Thank you very much. Bye now.